Okay, let us go ahead and get ourselves going again. So what I want to start with is really just setting the stage of the context where BIM came out of, and really what is the fundamental difference between BIM and some of the other technologies we've been used. And to think about that, it's actually helpful to think about just really the history of how we've communicated our design ideas like through the past. To just kind of put in a little bit of context so you can understand why BIM is so transformational. So let us start with this. It all started many, many years ago, if you really get back to the ancient structures that were built, with the whole notion of building physical models. People built physical models of what you'd have an architect who would actually go through and build a physical model of something like this that illustrates what it is you had in mind. Okay, and as a designer, you'd put this physical model was sort of really an interesting sort of doing it in that it had sort of an advantage in that the model, as you built it, really had to resolve in 3D. Because you could actually see what works in 3D and what doesn't work in 3D. It actually has to do that. Okay. It had some disadvantages, though, in terms of working with models. One of the disadvantages is that they were fragile, as people who saw me trip over this a little while ago realized. I now have a separable roof plan versus the floor plan, which wasn't really the way it was about half an hour ago. Okay, so it's a little bit fragile in terms of doing that. The other thing that's a problem with this, though, is that when it's time to communicate about this, I can invite you to come on up, and you can bring your calipers or your tape measure and kind of figure out what's going on here, then scale it up in your mind to kind of figure out exactly what it is you want to build. Okay, but we're sort of limited in that there's only one of these things. So if you want to figure out how to build this thing, you have to come to me. And I guess I like that because I can control it very much, but it's sort of limiting. But physical models did have an advantage in that they did in 3D. You couldn't hide a whole lot in a physical model because you can kind of look around and sort of see if things really do work one way or the other. Okay, so as we moved along, there's our beautiful physical model, a nice little 3D view of it from different sides. Okay, that actually worked out pretty well. Now, because of the limitations of physical models in Renaissance times, they came up with this brilliant idea that rather than trying to sort of give physical models as the primary way of communicating, we could come up with a way of drawing what the model is and representing it. So we could take a 3D object and a way to represent it in 2D. Okay, so the architect would create this representation in 2D, then the people who are going to build the thing have to interpret that and figure out what they actually meant by those. Now, inherent in that, there's this problem or a challenge in that, we have to come up with a common language, and I have to do a pretty good job of converting it into 2D in a way that you're going to understand on the other end. Because either way, if I don't accurately put it into the 2D or you don't accurately interpret my 2D, we could be in trouble, okay, in terms of accurately communicating what's going on. And that was really sort of the challenge. It was sort of a great efficiency in terms of what we were doing. However, there was sort of this room for error because there was two interpretations, me getting it into the form that looked sort of like a 3D model and you being able to reinterpret it. But we came up with a whole system of working with these. So we came up with the whole idea of what they called orthographic projections, and the idea is if you wanted to go through and do a plan view, it's pretty much you would just look straight down at it and draw what you see there. If you want to do an elevation view, you'd look at that, or you'd look at this, or like this. So we just project it, kind of a 90-degree projection, and draw the lines of what you see. They also have the whole notion of 3D views. It's continuing to die out here. Okay. This thing's been through a lot of construction detail. 3D views are available, but as people have done, has anyone done any 3D drawing? Like, it's a little work to go through and come up with axonometrics and isometrics and do different perspective views. So it's a little bit of work in terms of generating that stuff. But really the idea is if you could think about the orthographic projections as just being cameras on the model, that'll serve you very well when we start talking about building modeling. Okay, because that's fundamentally the principle of how we create different views in building modeling tools. Is we have a model, instead of a physical model, we have a digital model, but we're basically just manipulating cameras around that object as opposed to creating a series of separate drawings. And that has a lot of advantages. Okay, just to help you out, to give you some sense of perspective, I love to do this just because I still have access to these things. Okay. These are blueprints. If you ever wondered why blueprints are called blueprints, this is why. They are actually, ink that's drawn on linen, and then that linen was sort of laid over a surface where they could sort of project light through it, and where the ink blocked it, you got the white lights, and everything else turned blue. So that's why you have blueprints, okay? And these are from the 1920s. Okay, for a little house that I remodeled many years later. And I can pass these around for people to take a look at. What I want you to notice about these is, you kind of send those around a little bit. These are some elevation views you can take a look at. This is a floor plan view. And see these, there's actually 2 sheets of paper. There's actually 1 copy of the other. You send those just towards the back. Okay. That is the entire body of information that you're going to build the house with. Just that. Okay, go to it. I got some nice pictures. I got a floor plan. You're going to go ahead and figure it all out. And strangely, that actually worked. Because if you had very good craftsmen, we got to put that back in here. If you had very good craftsmen who were experienced at interpreting all this information, they could go through and figure it out, and they do a good job for you. So when they see these Spanish details and it says a wrought iron kind of window cover, they kind of create something nice for you that look like that. Okay. However, you're depending an awful lot on your craftsmen to do really good work for you because you really haven't given them very much to operate with. Now, a little bit later in time, take you to the 1960s, okay? People started doing hand drafting. So here's a nice little ranch house. This probably looks like a lot of the houses that you may have grown up in or your parents grew up in. Okay, you can sort of see in this drawing we have some, I'm just gonna leave that for you there and send them on back. We have some nice elevations, the front of the house. We have a plan view. We even have a little construction detail there, okay? Kind of showing how it's going to be built. Super. And then, if I move forward, there's a site view. This little block of information over here, this is the construction specification, okay, which is sort of right here. What is that? That's the contract, basically, that says what the builder is going to build for you in exchange for what you're going to pay them. So it says, oh, for example, for lighting fixtures, we're going to allow about $50 per lighting fixture. Talks a little about, oh, paint grade on some of the cabinetry and stuff like that. But this was it. These 2 pieces of paper were complete agreement with builder. It's just an incredible amount of information. If you've seen the set of documents for almost any modern building, like for the Y2E2 building where we are here, it's like a phone book. It really just looks like just thousands of pages of information that has to all be cross-coordinated and make sure that everything is in complete sync with each other. And anything that has thousands of pages with several thousand drawings on it inherently is going to have the opportunity for some miscommunication or some lack of coordination between everything. Just to give you a sense of perspective on it here, oh, I brought in some plans for just a couple houses. Houses aren't nearly as bad as like, some of the big buildings in terms of what's required. However, even this is back in like around 2000, you can see there's about 30 sheets in here of information, everything from the architectural sheets, through all the structures and construction details. There's just an incredible amount of information here to be coordinated. Okay, there's a couple different sets up here. If anyone wants to sort of actually look at them in any detail, they're actually out there on Canvas. So let me kind of just point them to where they are there for you. Let me go back out to files. But these are all just projects we've been working on. So if I go on out there, okay, the Powell CDs or the Graves CDs, you can take a look at those. So let me open up the Graves CDs, for example. And this is for a pretty simple, like a house here in Palo Alto. But let me see if I can go pop it around in here. There's 22 sheets in this one. Little house that got replaced, a little bit of a demo plan. That's pretty easy. You start getting into construction, just floor plans. We have roof plans. Start to see now, as part of the whole building modeling process, we can actually start to include 3D models, though. And that actually starts to make a difference in terms of people's understanding of what's going on. Okay, lots and lots of information in here. Sections through it all, construction details. There's just an awful lot of information that goes into any building set right now. And again, those are out there for you to take a look at if you want to. But the point of all this is that really what's happening is if we have these architectural drawings and we have them serving as the basis of the communication between the designers, the owners, the builders, and everyone who has to approve it, you start getting an incredible amount of information loaded onto those sheets because those sheets are really trying to serve a lot of purposes. And the problem with that is you don't always have consistency. It sometimes gets a little bit hard to kind of figure out exactly what's going on. So to demonstrate this, I'm gonna open up Revit, and we're gonna get a volunteer from our crowd right now who is a good interpreter of 2D drawings. Okay. Here's our little mystery house here. A lot of you probably have seen a house that looks something like this, okay? So if I give you a drawing that looks like that, okay, you know, we're gonna basically test how well you can draw what that looks like in 3D. Okay, does that make sense? Okay, now to test this, our gracious volunteer here, see if I can do this over here. Okay. Mr. Volunteer, we've practiced none of this. So go ahead and draw me in 3D what you think that house looks like.
Notwithstanding any lines that weren't shown. Or
that's the point of it, exactly. Okay.
Is there a erase function on this thing?
Yeah, hit the little, it's up there. Very good. It's got a fine hand, doing very well there. That's okay. It'll prove the point nonetheless. And if you want to laugh at his drawing, you can try this next, because it's actually, drawing in 3D is actually kind of hard.
This is without a ruler, so.
Yeah, I'm applauding you. I think it's actually looking pretty good.
I'm not talking to you, I'm talking to them.
You're fine. That's good. Doing very good at drawing in 3D. A lot of people have trouble with this. It's funny, I do this with clients all the time. You show them things and you show them 2D things and you want them to interpret in 3D. It's actually very hard for them. People swear they will understand something based on the 2D representation, but they really don't always. So that's a big advantage of 3D modeling. Okay, I think you're pretty good. Oh, now you're going for extra credit. No, it's okay, you're fine. Okay, so hang tight. You just hang tight there, and we're going to switch back over here. Okay, so we're looking at that. Okay, we're looking at our beautiful drawing here. Actually, what's your name? So, okay, so how many people think drawing is accurate right now? Or would you, well no one. Well, that's, you know how I work. That's like, it'd be too easy if it was that way. So let's go ahead and give Brad a little more information. That's the south side. Oh, so here's the north side. That's the other side of the house.
Okay, so there's a wing I'm missing.
Okay, well, go ahead and try and sketch it in quickly. What do you sort of think? Yeah. Okay, you got that little wing on the back? It's okay. Yours is on the other side of the house, but that's okay.
Yep, sure did. All right.
That's okay. Leave it there. That's fine. What's going on? Okay, so at this point, how many people feel like you have a pretty good understanding of what the house is? Would you be willing to bet some money on it? No, not quite yet. Oh, okay. So we might need to give Brad a little more information here. That's the west side elevation.
Okay. Erase my things on the wrong side.
Oh, that's okay.
I really wish I could draw this now.
All right. He's discovered there's a barrel vault roof across this thing. Didn't see that one coming, did you?
Well, there's no detail calling it out. So.
Exactly. Ah, that's exactly the point. Okay. The architect's going to send him one more drawing just to kind of really frustrate him. And this is the other side of the house. Okay.
Okay, so the way that's shaded looks like that's on a curve. So.
Ah, his discerning eye has noticed that, boy, that's not just 5 pieces of glass that are perfectly flat. That little bit of shading, oh, don't worry about it at this point. But basically, the point of all this is, if I give you 1 or 2 views, you may think you understand it, but you may not. It's really, really hard by giving you just a few views. And even in those thousands of sheets that came for describing the Y2E2 building, still may not completely understand it, because you understand what you see, but you don't understand what you can't see, and maybe it doesn't all resolve so well. So the point is, the only way that you can really start to understand it is to actually start to get to a 3D model. A 3D model that we can all move around, we can start to experience. Okay, and that's why we're going to be building 3D models. It's really just to kind of clear up that ambiguity, because as a single 3D model, what's going to happen is anything we do anywhere is going to be reflected in all the views, and it's just going to stay internally consistent. Okay, we'll show you an example of that in a minute. We got these drawings. It's hard to share a single design vision. In the world of computer-aided drafting, which was the first step towards sort of improving our efficiency, when we wanted to stop drawing things on paper like that, we came up with computer-aided drafting systems. And they had sort of a big advantage as opposed to drawing it on paper. You saw that paper going around. It's kind of fragile. If you have to erase things, things get in trouble. Computer-aided drafting was really all about efficiency. Like most things on the computer, if I could copy and paste them, I can just really quickly duplicate different things. And that's what it was all about. It was about making our drawing very, very quick. Okay. This disadvantage, though, the only limitation about that is that although we were doing it quickly, they were still just lines. They didn't really understand what lines meant. The lines were just lines. Okay, so we really didn't carry any intelligence. And because of that, okay, you ended up with all sorts of problems like this. So I love these pictures. These are this is what happens if you pay attention to the lines on paper, but you don't actually sort of apply some common sense. So that's an example of a driveway that might be a little bit hard to get up during the snowy times. This is a classic too. Stairways, you're going to find out, are very hard to draw accurately. So it's quite possible to end up with situations like this, which are a little bit hard to get from floor to floor. Kind of wondered about that. I assume the trait line is closed down. Okay. This is the escalator going up to the 2nd floor that, of course, someone's going to have some trouble with if they're over 3 feet tall.
Somebody put finish on the.
That's kind of a favorite, too. That's the ATM. That's just a little bit hard to use. Okay, and how do you do this? You do this because someone went ahead and did the plans, they did the elevations, but they didn't actually have the site plan in mind at the same time. So you end up with, and the silly thing is things like this actually get built. That's a fun one. That's a little bit tight, but it fit on the plans. And this is actually one of my favorites too. This is, again, what happens when the person installing the security cameras is working on one set of plans and the person installing the TV monitors is working on another set of plans, and they just never got themselves together. Okay, so you end up with stuff like this.